Hello, we're here with Daniel Povey, and our first question is, what is shallow fusion?
Hmm. Okay, well, so shallow fusion is something in the context of so-called end-to-end models. Now, normally these end-to-end models, the output of the network is going to be the log likelihood of basically the next token. And it kind of, in a sense, it includes the language model probability. It's already taken account the language model. But the idea of shallow fusion is that you have some kind of external language model that predicts the next token given the previous tokens only. And then you somehow interpolate that, usually in log space, with the actual model output. So it's kind of a hack because the model usually wouldn't have been trained in that way, but it enables you to adapt to different kinds of data because you can train your language model on text data only. You don't need audio. So basically, when we say shallow fusion, we just normally mean we interpolate the output log probabilities with language model log probabilities, usually with a scale of some kind. Deep fusion. Let's not focus too much on this diagram. Deep fusion would mean different things for different models, but basically it's going to be some kind of thing where you input some kind of embedding for the language model or something like that, and some output layer of the network reads that in and does something with it. It makes training a little bit more complicated, but you would expect it to be a little bit better.
Okay, and when do we use shallow fusion?
Well, shallow fusion can be used for pretty much any deep learning type of model, like CTC model or RNN-T or attention decoding, things like that. Yeah.
How and when did you use shallow fusion in Next-gen Kaldi?
Well, shallow fusion is one of it's a thing that we use in certain decoding algorithms. Like, so if by Next-gen Kaldi we mean Icefall, it has a lot of decoding algorithms. Like there's greedy search, there's beam search, there's greedy search with a graph, and there's ways to do rescoring with RNN-LMs. I don't remember all the names, like how we've called it in the code, but there's many different decoding methods, and some of them, in effect, they involve shallow fusion because they incorporate scores from some external language model.
Maybe it would be easier to understand it from the paper findings below. Can you comment on these results? Do you want to read the papers?
No, it's okay. I'll just comment. So, okay, so when they talk about multiplicative integration, this seems to be the one that performs best. I think it's the same as the interpolation in log space. It's just that they're describing it in probability space, so it becomes multiplication. And when they talk about density ratio fusion, so this is a very common thing when you do shallow fusion, that you have a language model, but the model kind of already contains a language model. So you want to cancel out the part of the language model that's already in the model. Now, just from this little snippet, I'm not precisely sure what it is they're canceling out, whether they no, it's okay. They're probably estimating a language model somehow from the training data and dividing by that. What we normally do in Next-gen Kaldi is we divide by right now we're often dividing by a bigram token level language model. We call that low order density ratio. The term comes from a paper from Tsinghua, and it seems to perform pretty well. Yeah, I don't know what they're subtracting out here. It could be language model from the training data. It could be some internal language model from the model itself. I'm not sure, but I don't think it's important to look into this. Okay, so this paper, improving accuracy of rare words for RNN-T through unigram shallow fusion. They seem to, according to this abstract, they're just boosting the probability of a list of rare words, and anytime they see the rare word, they just give it some fixed boost. What they say is they improve the performance on rare words by 3.7% word error rate relative. Now, this is kind of what we expect if we just boost up the rare words, because we're more likely to recognize that. So the word error rate just on that is probably going to decrease. They say that it doesn't give a degradation on a general test set. For me, another way of interpreting that result is that it just doesn't affect the word error rate. Now, it still is a useful result in a sense, because we generally care more about rare words than we do about, you know, short common words. So it might still be useful. Yeah.
Would
Maybe
you do
that's it.
this in Next-gen Kaldi?
I think we might consider it. I think we're more concerned about cases where there's a mismatch between training and test condition. So we'd probably want to do something like this for boosting words that that weren't encountered in training data. Whether or not that would like be stable, we'd have to test that.
Okay, thank you. That was Daniel Povey.
Right.